So we have done first lecture uh, about the concave mirror, hmm? Concave mirror, ray diagram, the characteristics of image depending on the different position. তো এইটা এই ভিডিও সেকেন্ড ভিডিও দেখার আগে ফার্স্ট ভিডিওটা দেখে নেবে, দেন ইট উড বি ইজি ফর ইউ। তো revision class, first revision, we know we have a concave mirror. So if we place an object, in front of the mirror, where at infinity, so consider this point is what? This is the pole. This one, this is the focus, and this is the center of curvature. Main point P to F, F to C, distances are same. At infinity, that time we observe when the object is at infinity, the image will form at focus. Then beyond C, then we can see it is between C and F. Between C and F, and it is what? Small size between C and F. So beyond C, between C and F. At C, if you place the object at C, then it is at C and same size. If you place between C and F, then we can see it is beyond C and it is magnified. Then if you place the object at F, then we can see the image will form at infinity, and it is highly magnified. The image will form at infinity. If we place the object between P and F, and then we can see the image is what? Virtual magnified, and it is behind the mirror. So here at infinity, position written, the position of the object, position of the image, it is clearly written. তো পরিষ্কার এখানে দেখা যাচ্ছে position of the object and position of the image. Today our topic is what? Convex mirror and the ray diagram of convex mirror. Then so today we will discuss about what? Today our topic is convex mirror. Okay, convex mirror means ray diagram. Actually, ray diagram of convex mirror and characteristics of image. It is for concave mirror. Then we derive mirror formula. Mirror's formula. Okay. So today we'll cover ray diagram for convex mirror, mirror's formula, derivation. With derivation, and then magnification. Okay. And before going to magnification, okay, we'll discuss about sign convention. So one by one. First ray diagram. So first ray diagram, remember ray diagram, then sign convention, then mirror formula and derivation. So ray diagram, then sign convention, then mirror formula, then magnification. So now start. The environment is what? Very calm. চারিদিক নিস্তব্ধ, চুপচাপ। No. So convex mirror. Convex mirror. And a convex mirror. How to draw the diagram for convex mirror? It is I can say this type of representation. So this is the convex mirror. This is the back side of the mirror and this is the front side. So again what we have to do, so this is a spherical mirror, this is a spherical mirror, but see it is bent along that side, this type of curvature. So if I draw one circle, and suppose circle to just normal try to leave it. So consider the sphere, consider the sphere, consider the sphere, and this is the transparent material. This is made up of, you can say, transparent glass. Now this is the center. If I coat this part, then it is the reflecting surface, and it is behaving like what? Concave mirror. It is concave mirror. If I coat this part, then it is acting as convex mirror. Convex mirror. So I am talking about this because of to find the center of curvature. So if I take concave, then that side center of curvature, no problem. As usual, we know this is our concave mirror. So this is the pole, it is the focus, it is the center of curvature. But if I take the convex mirror, so center of curvature that side. Is it clear? So if I take convex mirror, so center of curvature this side. This is a convex, so this side concave, that side. Now, so this is the convex mirror, and now let me draw the principal axis. So consider this is the midpoint, so it is the pole, and here you can say consider this is the center of curvature. This is the center of curvature, and imaginary line passes through the pole to the center of curvature C. Center of curvature C. It is what? C, point C, there, which is known as what? Principal axis. This is the principal axis. So is it clear? The first of all, if it is a convex mirror, then center of curvature that side, because just 30 seconds ago I discussed. Okay. Acha. This is the center of curvature. Now for a convex mirror, it is concept of focus. So what is the focus of a concave? What is the focus of a concave mirror? We don't know. When? How to find? Focus means what? As focus on your study means concentrate at a point. Concentrate. To put concentration at a single point. So here also, if we take the parallel rays, যদি আমরা parallel ray নেই, so when we are taking parallel rays means incident rays are parallel to the principal axis. Then we can see after the reflection, all the rays are passes through one point on the principal axis, and this point is called focus. So similarly, if we take the parallel rays, parallel to the principal axis, okay, set of parallel rays we are taking. After the reflection, so angle of incident, angle of reflection, so at this point, and this is the normal. If I draw the normal, then it will passes through the center of curvature, because suppose this is the sphere and this is the center. So if I draw normal means radius, then all the radiuses are perpendicular to the surface. Okay, 90 degree, 90 degree, 90 degree. So it is okay. So if I draw a normal at this point, so it means it is an imaginary line which is passing through the center of curvature. If I draw a normal at this point, so it is passing through the center of curvature. So this is the normal at this point. All the angles are measured from the normal. Don't confuse. See, confusion is going to jagah hi nahi. It is incident ray. This is the incident ray. It is also incident ray. I'm taking normal incident, so it will reflect back like this. So if I extend, then so you can ignore these. Okay, you can take these two. So this one and that one are incident rays. Acha, incident, the angle of incidence and angle of reflection are same. So all the angles are measured from normal. At this point, which is the normal? Normal, this is the normal, and this line, it is what? It will pass through the center of curvature, because one sphere and the radiuses are the normal to the surface. So angle of incident, angle of reflection are same. So it is reflecting in this direction. It is also reflecting along this direction. Okay. So if we extend, or suppose, for example, someone or you're observing the reflected rays from here. So what would be your observation? Your observation is what? You'll say, sir, the rays are coming backside of the mirror. Okay, means it appears, it is coming behind the mirror. So it is coming behind the mirror means if I extend this reflected ray over here, so we can see all the reflected rays. If I take infinite number of reflected rays parallel, they are reflecting. So you can see all the reflected rays appears to diverge from this point, and this is known as the focus of the convex mirror. So this is the focus of the convex mirror. This is the focus of the convex mirror. তো যখন convex mirror এর উপর parallel ray গুলো এসে পড়ে, okay, so after the reflection they appears to diverge from a single point. এই পয়েন্ট থেকে ডাইভার্জ হচ্ছে বলে মনে হয়. So and this point is known as what? This is the focus. So we can write two more point. In case of concave mirror, the focus, it is the real focus. Okay, and for convex, it is virtual focus. It is real focus, and for concave it is real focus. Really they intersect, they meet. And for convex they appears to diverge. এরকম মনে হচ্ছে আমাদের যে এই পয়েন্ট থেকে ডাইভার্জ হচ্ছে. ক্লিয়ার? ইজ ইট ক্লিয়ার? তো ওকে, গুড. তাহলে এইটা কি হয়ে গেল? দিস ইজ দি ভার্চুয়াল ফোকাস অফ কনভেক্স মিরর. ভার্চুয়াল ফোকাস অফ convex mirror. This is the focus of convex mirror, and for convex mirror the focus is virtual. Is it clear? Now ray diagram. How to draw the ray diagram? So here also we have to remember rules in case of concave mirror. In case of concave mirror, we draw like this, 3 steps. Okay, 1, you can follow 3-4 steps you can follow. So this is pole, it is focus, center of curvature, pole, focus, center of curvature, pole, focus, center of curvature. So when the incident rays are parallel to the principal axis, after the reflection passes through the focus. For concave, remember, then if you don't know, then go to class 10 light 1, reflection from spherical surface, spherical mirror. Acha, then see lecture 1. This is what? Class 10 light 1. This is class 10 light 2. Acha, then when it is focus, though it is center of curvature, it is focus, it is center of curvature. Next one, when the ray is passing through the focus after the reflection, it must be parallel to the principal axis. Means we can draw the ray diagram by using this step, and we are using this method to draw the ray diagram easily. If we are able to draw the ray diagram easily, then we can say, we can write the characteristics of image and we can utilize in our real life. Acha. Then whenever some rays passes through the center of curvature, then it will deflect along the same path in opposite direction. Okay, and for oblique incident, say this is the incident, so it will be the reflected, so that angle I and angle R remain same. So 4 rules you have to remember for concave. Now for convex, this is the convex lens, so we can write rules. So this is the convex, so this is the virtual focus, okay, and this is the center of curvature. Again, this is the convex, this is the pole, then focus, and then center of curvature. So again, if the incident ray is parallel to the principal axis, so after the reflection it appears to diverge. After the reflection it appears to diverge from the focus. So if the incident ray is parallel to the principal axis, which is the principal axis? This is the principal axis. So if the incident ray is parallel to the principal axis, so after the reflection it appears to diverge from the focus. Achha, next one. Suppose it is for normal incident. So for example, some ray it is coming like this. Normal incident, I am taking normal incident, or you can take oblique incident. So in case of oblique incident, this is the incident and it would be the reflected ray, so that angle I and angle R remain same. Okay, third one. One minute. Sorry for this inconvenience. Acha. So this is what one. If it is parallel, so it is what appears to diverge from the focus, and then oblique incident I and R to be angle I and angle R remains same. Acha, now another one, say convex. It is the convex too. This is the convex mirror. Acha, this is the focus, and it is what considered. This is the center of curvature. It is the focus and it is the center of curvature. This is the pole. So somehow, clear na? Whenever we are drawing the ray diagram, যখন আমরা রে ডায়াগ্রাম আঁকছি, হতেই পারে যে আমরা নিচ্ছি কি যে ওয়ান রে ইট ইজ গোয়িং টুয়ার্ডস দি ফোকাস, মানে এমনভাবে ইনসিডেন্ট হলো যে এটা ঠিক ফোকাসের দিকেই যাচ্ছে, তো ইট ইজ মুভিং টুয়ার্ডস দি ফোকাস। দেন আফটার দ্য রিফ্লেকশন it must be parallel to the principal axis. So if the direction of incident ray is towards the focus, after the reflection it will be parallel to the principal axis. Again maybe we are drawing one incident ray, we are considering one incident ray where the direction of incident ray is towards the center of curvature, like this. So it is, if I extend, then it will reach the center of curvature. So if the direction of incident ray is towards the center of curvature, then it will reflect along that direction only. So this is called normal incidence. It is called normal incident. Normal incident case. So case 1, if it is parallel, appears to diverge from the focus. Then oblique incident, angle I and angle R, it will remain same. And so when the incident ray, okay, moving towards the focus, when the incident ray is moving towards the focus, or it is reaching towards the focus, or it is going towards the focus. So after the reflection, it should be parallel to the principal axis. Next one, another one ray, and we are taking, and the direction of incident ray is what? It is toward the center of curvature. So it will reflect back along the same path in opposite direction. Why? Normal incident. Because it is a normal incident. The angle of incident, angle of reflection. Here, in case of normal incident, angle of reflection, angle of incident is what? 0. So for example, this is the, you can say, one plane surface, and it is the light. It is moving along this direction. For normal incident, it will bounce back. It will deflect. So all the angles are measured from the normal. So the incident direction is what? Along the normal. The angle I and angle R must be 0. So here also must be 0, and it is moving in opposite direction. Now come to the ray diagram. Now come to the ray diagram. Ray diagram, ray diagram, ray diagram. Offer. Ray diagram, ray diagram, ray diagram. Convex mirror, convex mirror, convex mirror. Achha. So say this is the convex mirror. So for convex mirror, 2 ray diagrams. One for definition of focus, already you have done. Now second one, for example. So this is, consider it is the focus, and sorry, this parallel. So consider this is the center of curvature. Center of curvature and focus are equidistant. So let me write this is the center of curvature, focus. And I am taking one object. It is what? Here. Very far. Okay, and next we will shift this object towards the mirror. So I am taking here, I will take at mid, and will take very near to the mirror. To see. Acha. So ray diagram concept is what? So this is the object, this is the mirror. So this point is what? It is the pole. It is the pole, focus, center of curvature. And I am taking one ray. So first I am taking, it is a parallel. So when it is parallel, so after the reflection, it appears to diverge from the focus. Ray parallel. So for convex mirror, when it is parallel, after the reflection, it appears to diverge. So I am using the trick. It appears to diverge from the focus. 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 So I am using the dotted line. Okay, so it appears to diverge from the focus. To show it, it is appears to diverge. So I am using dotted line. I used here dotted line. So one, for ray diagram, minimum condition is what? You have to take minimum 2 rays. So another one I am taking. Another one is what? You can take oblique incident. You can take one incident ray which is focus seeking, or means it is reaching towards the focus. You can take one incident ray which is reaching towards the center of curvature. Then it will reflect back along the same path. So it doesn't matter. Take any one. So this is another one concept. So you can take oblique incident, I'm taking focus seeking, or you can say towards the center. So your choice. So I'm taking one ray which is moving towards the center. So I'm taking one ray which is moving towards the center, which is moving towards the center. So I am taking this one which is moving towards the center. So one ray parallel, it will deflect back and gets diverged from the focus, and I am taking one center of curvature seeking incident ray that is moving towards the center of curvature. So it is normal incident, it will deflect back along this direction. So if I extend these two incident, already extended, that's why I use that T dotted line. প্রথমে dotted line টা করে তারপর আমি এটা draw করে দিলাম, তাহলে কি হবে, easy. So you can see they are meeting at this point, means appears to meet at this point. So the image will form here. You can see this is the image size. Okay. And if we take this object here also, then we can see the image size is also, it is what, very small compared to the object. Okay, is it clear? So in case of convex mirror, the image is always virtual. Image is virtual. So virtual image is virtual. Image is what? In case of convex mirror. In case of convex means the mirrors used in cars. Used in cars. तो गाड़ीते जे मिरर गुलो यूज करे व्यू मिरर, तो we can write view mirrors. View mirrors for cars. So it is what? It is a convex mirror. It is the convex mirror. Okay. It is a convex mirror. The image is virtual. Then you can write small sized. Small size. Okay. Then, or you can write diminished. Okay. As a virtual image, virtual as it is, so we can write upright or erect. Upright or erect. So virtual image always upright and erect. যেমন object তেমন. For example, you are standing in front of a mirror. So the same type of, suppose you are riding a, you can say you are driving a car, you are riding a motorbike. So that time you can see the object behind you. So those are as it is, not inverted, ulto na. Okay. So that's why it is written what? Upright, erect. So for a convex mirror, it is upright and erect image. So clear? So you can see it is in case of convex mirror. In case of convex mirror, image height, the height of the image, and it is height of the object, height of the image, height of the object, it is what? Less than 1. And it is known as magnification. So magnification is less than 1. Mathematically we are finding ratio. So how to write in terms of mathematics? So height. So if it is small, then it is less than 1. If it is same, equal 1. If it is big, then greater than 1. Simple mathematically, and এটাকে নাম দিয়ে দিয়েছে ম্যাগনিফিকেশন. যদি বড় হয় ম্যাগনিফিকেশন, তাহলে ম্যাগনিফাইড ইমেজ লিখবো, ছোট হলে ডিমিনিশড লিখবো, ইকুয়াল হলে সেম সাইজ লিখে দেবো. তো উই ক্যান সি ইট ইজ what? Small size. Small size means diminished. আচ্ছা, virtual image is what? Virtual means it is behind the mirror. Virtual means, so virtual meaning of virtual, it will form, so it is forming behind the mirror. And in case of real image, it is in front of the mirror. In case of real, it is forming in front of the mirror. or virtual, it is behind the mirror. Okay, clear? Done. Any point missing. So behind the mirror, virtual, small size, magnification, upright, direct. Okay. Achha. Okay. Now next. So how to draw? You can take different methods. This is two though. It is what when it is moving towards the center. Now I am showing another two steps also. I am showing another two steps how to draw the ray diagrams. So I am taking first it is towards the center of curvature. Done. As a next, for example, I am taking it is moving towards the focus. First it is parallel. Next I am taking it is moving towards the focus. So now height of the image you can erase it. Another one, bhalo kore bosh, ठीक? अच्छा, I am taking another one. Say it is what? This ray, it is moving towards the focus. So I am taking one ray which is moving towards the. I am taking one ray which is moving towards the focus. It is moving towards the focus. So see, when the ray, okay, coming towards the focus, after the reflection, it must be parallel to the principal axis. So when it is moving towards the focus, so I am using the dotted line to show. I'll erase this part. Okay, this dotted for to draw the extended reflected ray. Okay, achha, that is incident. That is moving towards the focus. So after the reflection, it must be parallel to the principal axis. Now let me extend the reflected ray. So you can see at this point again I am getting one small sized image and it is virtual. Okay, this is the step 2. You can see, correct? Now third step I am showing. Be careful, very interesting. Third step I am showing. So in your book only one step or two steps are given. Only one, and most of the cases one step. This one and oblique. This one oblique, or you can say moving towards the center. As another one. If I take the oblique incident, means one ray is coming along this direction. So all the angles are measured from the normal. It is angle I, and this is the reflected ray, and this is angle R. So what we have to do, I have to draw the you can say extended reflector. So it appears to come from that side behind the mirror. So we can see this is the image. Okay, this is the image. But don't think, sir, it is too quite weak. Characteristics. It is smaller, so diminished. Is it clear? Always diminished. Magnification less than 1. Always will get. That is a small sized image, virtual, erect. So everything we are getting same. Okay. Now convex mirror part is done. Next we'll discuss about the mirror formula. Next we'll discuss about the mirror formula. To derive the mirror, first of all, mirror formula is what? Mirror formula, it is nothing but the relation between object distance, comma, image distance, as object distance short u, good, image distance v, and focal length. Okay, focal length, that is there. So relation between u, v and if it is for reflection, it is for reflection case, it is mirror formula. It is mirror formula. Okay, and same relation between UV and F in case of refraction, that is lens formula or lens maker formula. Is it clear? The mirror formula, it is what? Formula is 1 by V plus 1 by U is equal 1 by F. So this is the mirror formula. The relation between image distance, object distance. This is what? Object distance. It is image distance. It is focal length F. So this is the relation and we'll derive this one. Okay. Chalo. Clear? So what is mirror formula? It is nothing but the relation between object distance, image distance and the focal length. This is the mirror formula. Okay. So after the mirror formula, we'll discuss about the magnification also. This is about the magnification. And next, light 3, next lecture we will discuss about, we will solve some mathematical problem. Okay? So mirror formula. So see, first you do one thing. First, now let me place the mirror. So suppose this is the mirror. This is the mirror. Clear? So let me check at first. Yes, good. So first, consider this is the mirror. Next, what is this? This is the principal axis. So say this is the principal axis. So this point is what? This is the pole. As I am taking, this is what? This is the focus, and I am taking this one. This point is center of curvature. Okay, this point is center of curvature. So we know P2F and F2C are same. P2F and F2C are same. So let me put this point over here. So P2F and F2C are centimeter. Now, to prove this one easily, let me place the object over here. So consider this is the object. Okay, extended using arrow, using dot, it does not matter. So we have to take one incident ray. So I am taking the rays coming from that side, or it is passing through this point and it is reflected through this surface. So I am taking one object. Okay, you can take the object at C, between C and F here, but I am taking the object over here. And consider this is the incident ray. This is the incident ray. So this is what? This one, it is the object. So let me write, it is the object. This is the object. So object থেকে একটা রে গিয়ে সারফেসে হিট করেছে। Done? So one, and we know we have to draw the reflected ray also. But here remember, reflected ray, all the angles are measured from the normal. So at this point, can you tell me? At this point, what is the normal? So, yes, you are correct. The normal is the line which is passes through the center of curvature. So center of curvature যে dotted line টা যাচ্ছে pass করে যায়, this is the normal. And angle of incident and angle of reflection are same. So consider this is the reflected ray. Okay, consider this is the reflected ray. Sorry. So scale the drop only better. So this is the reflected ray. Two rays to required. I am taking one ray which is moving along the principal axis, and after the deflection it reflects back or bounces back in opposite direction. So now this is one reflected, it is another one reflected. So this point is what? This point is the image point. Image point. Okay, I'll consider it is the image. Image point means is not point sized image. Image point means the image is forming over here. Is it clear? Image is forming over here. It is the focus, a different one. Okay. Achha. So now another one. Now I'm writing one by one. Suppose I'm taking the angle between this incident ray and the principal axis is I am taking what? It is I am taking alpha. Angle between reflected ray and principal axis I am taking beta. And angle between the normal and the principal axis I am taking gamma. It does not matter, means whether you are taking it is alpha, beta, gamma, theta 1, theta 2, theta 3, phi, psi, gamma, beta. Angular notation you can consider alpha, beta, gamma, phi, psi, okay, then theta, okay, you can capital, you can use 1, 2, 3, does not matter. So just remember it is what? Alpha, it is beta, it is gamma, and here we have to use two concepts. First concept is what? There is one pure mathematical theorem. Suppose you have one triangle and this angle is what? It is called exterior. And these two angles are interiors. Okay? And it is what? Opposite interiors. So if I write exterior E and it is opposite interiors 1, it is if I write theta 1 and theta 2, and if I write this one is what? It is, say I am writing it is phi. So exterior, this phi is equal theta 1 plus theta 2. Okay? So exterior, so it is what? The value of exterior, it is sum of two opposite interiors. Theorem. Then another one, in case of right angle triangle, if I consider this is the angle, it is 90 degrees, then it is base and it is height. And I am writing this angle is for I am writing theta. So it can be written as tan of theta is equal what? H by B. Then height by base. These two concepts. We will not make it confusing. So let me write, I am writing it is what? I am writing it is psi. So tan psi is equal H by B, means with respect to this angle. This is height, it is base. Done. So similarly, suppose this angle, it is what? Angle of incident. Say it is what? Theta. So if angle of incident is theta, now tell me what is the value of this angle? Say it is also theta, because angle of reflection. So angle of incident theta, angle of reflection is also theta. Done? So now let me put some name here. So this is the object. I am writing over this is A. I am putting one point, say it is B. C already given. And F point is also given. And this is what I am writing, it is I point for image point. Okay, and this is P. So see, for triangle A B C, for triangle A B C, for triangle ABC, for triangle ABC, we can write it is what gamma is equal exterior, it is sum of opposite interior, alpha plus theta. Is it clear? This is gamma, it is alpha plus theta. Done? Achha. Now if I take another one triangle, triangle is what? Say CBI. So I am taking another one triangle. For triangle CBI. So we can write beta. This exterior what is beta? So exterior is beta is equal sum of interiors. So we can write gamma plus theta. We can write gamma plus theta. Then we can write gamma plus theta. Okay, leave it. Now move to that side. Up to this clear? So up to this, now leave it. Now come to point. Come to the point. Achha. This is what? It is what? Sir, it is ray. It is what? Sir, it is light chapter. Achha, light is a part of optics. Okay, or optical physics. Optics. Sir, optics, it is which optics? Sir, two branches. One is physical, another one is geometrical. Achha, this is what? It is ray optics. Or ray optics, another name of ray optics is what? Geometrical optics. Physical optics, you can say it is what? Wave optics. Okay, now ray optics, it is what? Geometrical optics. So we have to use geometry. We have to use the geometry because ray optics, it is what? Geometrical optics. So we have to use geometry to show this one. So that's why what we are going to do, I am drawing one normal from this point. So I am drawing one normal from this point. So I am drawing this one. This is the drawing. So what I have done, I draw one normal on the principal axis from the point B. So I am getting this angle is 90 degree. Okay. Now see. So one by one. So we have one big, then second one and third one, three triangles. So what you have to do? So we have three right angle triangle. One is what? B. So let me put this point is what? D. This point is D point. This is D point. This is D point. Achha. So triangle, it is what? B, okay, then D and A. From triangle BDA. So triangle is what? Triangle BDA. D is 90 degree. D is 90 degree. Or it's better if I write it is what? Triangle, it is right angle triangle. Let me take the alpha. So we can write this is the alpha, this is alpha. This angle is alpha, so triangle BAD. So here this angle is what? BAD. I am taking BAD triangle. Achha. So from here we can write tan of alpha. Okay. Slowly try to understand. Dhire dhire. For this triangle BAD, and just in your mind just remove this part. So we have the triangle BAD. This is the triangle. So tan alpha it is what? We can write it is what? BD divided by DA. It is DA. Is it clear? Clear? So BAD, this one, this triangle. If I put the shade now, then it will be difficult because it is the whiteboard. I can't erase this one. Then I have to draw the diagram again. As I am showing, this is BAD. This triangle BA and D. This one. So tan alpha, it is height divided by dA base. Next one I am taking BCD. I am taking one triangle. Again, this one is what? It is gamma right now. The triangle name is what? B, C and D. We can write here tan gamma is equal again B D divided by DC. So if I take B C D B C D B C D, so this triangle, then we can write it is what? Tan gamma means then BD by base. Next we have one triangle. This triangle, it is the triangle is what? Now I am taking this angle is, it is what? Beta. I am taking this angle is beta. So instead of this, if I draw the triangle like now, it is okay. This is alpha. Now this is gamma, and now this is beta, and now this is beta. The triangle name is what? Here B, then A, and then D. This it is what? B, C and BCD. This angle is what? B, then I. This is point to I. It is different. It is I and D. So from here we can write tan beta, not alpha, sorry, beta. This beta. This is what? Again height by base. So BD divided by DI. Is it clear? Up to this clear? So just the mirror, incident ray, reflected ray, normal, it is image point, object alpha, this is beta, gamma, and this relation, it is what? Exterior is sum of the opposite interior. So for this triangle, gamma alpha plus theta. For this triangle, it is beta gamma plus theta. Is it clear? Now let me prove this, and then I will use the different color to show the triangle. Otherwise now it is clear. Main point, okay, remember, this is geometrical optics, and remember these though I am showing these incident is striking over here, but in case of in real case, this incident ray is the ray is striking very near to the pole. Okay, so this is what exactly this ray striking very near to the pole, and that's why this is valid for paraxial rays, PARAXIAL, paraxial rays, or you can say paraxial approximation. So under paraxial approximation, this is what this B point is very near to P. So paraxial ray means the rays are parallel to the principal axis. So this point is very near to pole. So try to understand, if this point is very near to pole, these alpha, gamma, beta are very small. If this line is very near to pole, these alpha, gamma, beta are very small. So see, I am drawing one, say this is the triangle and this is the angle. I am drawing another one triangle. When this angle is very small, the angle is very small, so I am drawing one triangle over here. The angle is very small. Then you can see base to remain same, b remains same. This is height, it is b, and height you can say reduced, very small. So here tan of some angle, say right theta, it is what, height by base. So if theta tends to 0, then height also tends to 0, and if height tends to 0, then something very small divided by b, then it would be tends to 0. So if theta tends to 0, then the value of tan theta also tends to 0. যদি অ্যাঙ্গেলটা অনেক ছোট হয় তাহলে দেখতে পাচ্ছ হাইটটা কমে যাচ্ছে, তাহলে বেসটা একই, হাইটটা ভেরি স্মল, তাহলে কি হলো, h by b এটা অনেক স্মল। তো ফর থিটা tends to 0, we are getting tan theta tends to 0. So means we can write for small angle, so we can write for small angle, we can write for small angle theta, okay, or we can write tan theta is theta for small angle. And paraxial approximation, this point is very near to pole, so under paraxial approximation we can write tan theta is theta. The value of tan theta and theta are same, okay. So it is very, the angle is what, very near to 0, then tan theta is also very near to 0. So remember, so now for small angle, paraxial approximation means actually this point is over here, and then we can draw the parallel, nearly parallel to the principal axis. So that is the paraxial approximation. This is the paraxial approximation, okay. So under paraxial approximation, this is valid. And when theta is very small, theta tends to 0, then tan theta tends to 0, means we can write for small angle tan theta is theta. So similarly we can write here, instead of tan alpha, we can write alpha is equal BD divided by dA. Similarly we can write gamma, tan gamma, so gamma is also small, because this angle is small, so alpha beta gamma are small, so tan gamma can be written as gamma, and it is what, BD divided by DC. Similarly tan beta can be written as beta, it is what, BD divided by DI. Done? Okay, note it down, very interesting. Done? Acha, so means we have the relation between alpha gamma beta, alpha beta gamma. तो सर थीटा तो नहीं चाहिए, थीटा तो दरकार नहीं, we don't want theta, so we can do one thing, substitute the value of theta. तो থিটাটাকে আমরা তাড়িয়ে দিয়ে একটা রিলেশন তৈরি করি। নাও সি, তো ক্যান উই রাইট this one, theta is equal, say let me write, this is what, equation number 1, and from here I can write theta is equal beta minus gamma from this, and this is what, equation number 2, and now put the equation 2 in equation 1. So I am putting this here, so I am getting gamma is equal alpha plus beta, or plus beta minus gamma. So let me shift this minus gamma over this side, so I am shifting this gamma this side, so I am getting 2 gamma is equal alpha plus beta, or you can write alpha plus beta is equal 2 times of gamma. So now I am getting these equation, and now put the value of alpha, beta and gamma in this equation. Say it is equation number 3. So put the value of alpha, beta, gamma. Let me check, then I'll write over here. This part is visible up to this. Okay, let me erase. So you do one thing, you write it right, draw and then write it. 1 minute, let me erase this part so that I can write it. Otherwise this part is visible. This is visible up to here. No, up to this. Up to this it is visible. Up to this it is visible. Yes. Up to this it is visible. Yes. So let me write it over here also, because up to this it is visible. And let me erase this line. Achha. So see, alpha plus beta equal to gamma. So now put the value of alpha. So alpha it is what? So we can write alpha it is what? BD. So from equation 3 you can write from equation 3. From equation 3 we can write it is what? Alpha means it is BD divided by DA. Achha, plus beta. Beta it is what? Plus BD by DI. PD by DI. Achha, is equal 2 times of gamma. It is what? BD by DC. Achha, take BD common. Take BD common. I am writing over here. So BD common. BD. Take BD common. So BD common and then cancel out. So we can write it is what? 1 by dA plus 1 by di is equal 2 times of 1 by dc. We are getting here. Let me check. Yes. Then I can write here also. Achha. So see, so 1 by dA plus 1 by dA done. Achha, dA. What is the value of dA? See, we as we discussed, it is what? Under paraxial approximation. Means when this ray is actually very close to P. So see, if this D point is over here and you are drawing one normal on principal axis, be careful. Suppose this is this one. In case of drawing we are showing this is the incident ray, but this is what? It is very, and this is the pole. If it is very near to the pole, okay, and if you draw the normal, so these D point and P point are actually very close. So this D point D very close to P. Same. Yes. So see the distance DA. Okay, DA means D to A. So it is what we can consider this pole. This point, D point is very near to pole. Under paraxial approximation, this point is over here. So if consider this point is very close to P, over this point. So if you draw one normal, so it is nearly P now. So this DA, it is what? It is what? Exactly equal, we can write it is PA under paraxial approximation. So these D point and P point are same. So where DA given, DA, we can write PA, and pole to object, it is known as what? Object distance. Good. It is known as object distance. Actually, direction is what? Opposite to the incident ray. Because this is the direction of incident ray. I am taking opposite to the incident ray. So it is what? Minus. Very good. So we'll write here. Let me write here. So from here to here I am writing. So we can write it is 1 by V, and it is opposite to the incident direction, so I am writing here minus V, plus similarly 1 by di means p to I. It is what? Sorry, it is the object distance. So it is denoted as u, not v. Sorry, it is u. This one here to here, object to u. As an image, so again di. So it is nearly to we can write pi under paraxial approximation. So we can write it is what? Pi means it is v opposite to the incident direction. It is negative. Is equal 2 times of 1 by 2 times of 1 by c. It is given what? It is given dc. So means p to c. P to c is what? Radius of curvature. So you can write it is r with minus sign. Okay, let me check it's okay or not. Up to this minus, is it visible? Yes, good, visible. Achha. So now this is negative, 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 cancel, negative, cancel. And r, we know relation between r and focal length is what? R equal 2 times of f. So just put over here, we can write 1 by u plus 1 by v is equal 2 times of 1 by 2f. So 2 cancel, we can write 1 by v plus 1 by u is equal 1 by f, and this is our mirror formula. So initially we wrote 1 by v plus 1 by u plus 1 by v, or 1 by v plus 1 by u are same. So just matching that initial expression, just I am writing 1 by v plus 1 by u plus 1 by v. So this is the relation between object distance, image distance and focal length. Okay, is it visible? Yes, this is visible. So you can see it is written. So this is the derivation of mirror formula. I hope it is understandable, or you can understand this one. Okay. Understood? Next, write it. Next we will discuss about the magnification. So I am erasing this one. Let me erase this part, and next our topic is what? Magnification. So before going to magnification, just few sentences you have to remember. See, I am drawing here in this side concave and convex. So if I draw, so this is what? Concave mirror. Then as a sign convention, once again, sign convention. Suppose I am taking sign convention, so I am taking this is the direction of incident ray. This is what? This is the pole. Achha. Another one point, all the distances are measured from the pole. So all the distances are measured from the pole. See, we know in case of concave mirror we have only one case, that time when if the object is placed between P and F, only in that case you will get one virtual image. So see, all direction, this is the incident direction, the object, so it is the incident direction. All the distances are measured from pole. So see, if we get the image here, the pole to object, so this is the direction of incident ray. Suppose you are here and you are moving along this direction. তো along the direction of incident ray, তো পোল থেকে ডাইরেকশন অফ ইনসিডেন্ট রে দিকেই আমি মেজার করছি, পোল টু অবজেক্ট। So for this case it is what? Positive. So for this case V is positive. Achha, if this is the object distance, so pole to the object, it is pole to, so you have to move along this direction and it is opposite to the incident ray. So for this U is negative. And remember, always U, okay, U is negative. Always U is negative. So for mathematical question, mathematical problem, we have to put the sign convention. With sign convention we have to use. Okay, so always U is negative because object distance always negative. So always U is means object distance, OBJ DIST. Object distance is negative always. So U is always negative, always. For in case of concave, convex, any case U is negative, negative, negative. Then for concave, so remember this one, for concave, convex. For convex, so for convex, this is the convex. So this is the convex. Acha. So if I place one object over here, then for all the cases the image is small sized and virtual. We know in case of convex mirror, center of curvature, focus this side, and center of curvature is also this side. So for convex, all the distances are measured from pole except U, V positive, and this is the focus, so F positive, and radius of curvature is also positive. So only U negative. So for convex, only U negative and object image distance, focal length are positive because this is virtual focus. So because it is virtual focus. Because it is virtual focus. So it is virtual focus. So for virtual case, it is positive. So virtual image, if the image is virtual, then image distance always positive. Remember, if the image is virtual, image distance always positive. So just remember, if the distance along the direction of incident ray, taken as positive, direction of incident ray, all the distances are measured from the pole direction of incident ray. So I am writing here, so direction of incident ray taken as positive. Okay, so along the direction of incident ray, I am writing along the direction of incident ray taken as positive, and opposite taken as negative. So see, in case of concave mirror, focus to this side. So in case of concave mirror, focal length, which is pole to focus, this pole to focus, it is focal length. Okay, pole to object, it is what? Object distance. So U is object distance, V image distance, and F focal length. F is focal length. So in case of concave mirror, again let me draw it, you also draw. So in case of concave mirror, so this is the concave mirror, it is the pole, this is the focus. This is the center of curvature, Say the object is over here, so we'll get the image this side. It is real image. So see, all the distances are measured from pole. So pole to focus, this is pole to focus, this distance opposite to the direction of incident ray. This is the object, so this is the direction of incident ray. भाई जिस तरफ ऑब्जेक्ट है इस तरह, इफ दिस इज द ऑब्जेक्ट, এটা যদি অবজেক্ট হয় তাহলে লাইটটা এদিক থেকেই তো যাবে। সো দিস ইজ দ্য ডাইরেকশন অফ ইনসিডেন্ট রে। বোঝা গেল তো? সো দিস ইজ হোয়াট ফোকাল লেন্থ এফ। তো ফর কনকেভ এফ নেগেটিভ, তো নেগেটিভ এফ, then u always negative, v negative, except if the object is placed between p and f, that time we will get virtual image. If you place the object here, then we will get image here, that time v positive. So if for between p and f, when the object is placed between p and f, that time you will get v here, and this is the image distance, then write plus. So plus v when if the object is placed between p and f, if the object is placed between p and f, that time only v positive, otherwise v negative. So only one case. And for convex, v positive, f positive, u negative. Is it clear? So mirror formula is what? 1 by v plus 1 by u is equal 1 by f. So don't write minus minus minus. This is the formula. This is the formula. Okay, this is the formula. So what we have to do? For example, again I am drawing one diagram. Okay, concept. Try to clear your concept at first. Then you can solve any mathematical question. So now, say this is the concave lens. Concave mirror, and this is the principal axis. So consider this is the focus, and this is the center of curvature. Say from here to pole to focus distance is, focal length is given 20 centimeter. Okay. Acha. Say the object is here, and this distance is what? From the pole to 30 centimeter. This distance is given 30 centimeter. And image is forming over here, and it is what? Say 50 centimeter distance. Okay. Just without calculation I am writing. For example, don't put the values and don't say that it is to not matching, just arbitrary value. So for this case, now tell me what is f? So f is equal 20. Now minus 20, because it is opposite to the incident direction. If this is the position of the object, so direction of incident ray is 1. If you place the object here, then the ray will move along this direction. So it is the direction of incident ray. And all the distances are measured from the pole. So pole to focus minus 20. As a object distance, it is u. So in place of u, what you have to put? 30. No, minus 30. As a this is the image. The image distance v, what you have to write? 50. No, minus 50. Arbitrary. Don't put here and don't show that it is not matching. No, just for value. So can you write the values? Yes. So for this case you can write it. Achha, now let me change this one, and for another one case, and say this is the concave mirror, and this is the object we are getting. This is the image, focal length over here. So now tell me, say again it is 20 centimeter. This is given 20 centimeter, and this is 5 centimeter. We are getting 10 centimeter. So see what is u? What is V? What is F? Tell me. So U is what? Object distance are always negative, minus 5 centimeter. V image along the direction of incident ray, this side behind the mirror, sir, plus 10 centimeter. F for concave, so sir it is real focus, real, so negative, real focus that side, that is what? Minus 20 centimeter. That is the concept. Okay, similarly, similar concept for the convex also. For convex, V positive, F positive, U negative. So our formula is what? 1 by V plus 1 by U is equal 1 by F. So suppose F is not given, object distance and image distance given, they are asking find the value of F. They are asking find the value of F. So how to find for this question? How to find? So we have to write this formula. 1 by V plus 1 by U is equal 1 by F. Now put the values. So V equal 1 by minus 50 plus 1 by minus 30 and it is 1 by F. So LCM is what? LCM is 150. Take minus common and put here. Okay. Taking minus common and we are putting this minus here. Acha. So 150, it is what? 3 plus 5, 1 by F. So now shift this minus here. We can write minus 1 by F is equal 8 by 150. And LCM though 30 and 50. So LCM it is what? By 2, 15, 25, by 5, 3 and it is 5. So it is what? 15, 75 and 2, 150. So now we can write minus F is equal 150 by 8. So minus F equal, so now divide 8 ones are 8 and 70, then 64. Just divide now. 150. So 8 ones are 8, 7 70 and 8 8s are 64. Then 6. So we are getting 18 point something. Okay. So focal length is 18%. That time I arbitrarily I put the value of F. Nearly 20 I put. So it is what? Near 18 point something we are getting. So like this we can find. So what you have to do at first draw the diagram, place the object, what is given, write it, consider the sign convention, whether it is positive or negative, and then put the values. Is it clear? Then you will get the correct answer. So sign convention. Along the direction of incident ray positive and opposite to the direction of incident ray it is negative. From where you have to measure the distances? From the pole. So along the direction of incident ray positive, opposite to the incident ray negative, simple. Okay. Is it clear? Okay, so up to this enough. Magnification, next lecture I'll provide the magnification topic. And clear? Then you do one thing, practice. Okay. see the video. If you have any problem, then go to the previous one, class 10, light 1, reflection from spherical mirror, reflection from concave mirror. Okay. Then see this one. Then you can draw the ray diagrams. You can solve the numericals. Okay. You can clear your concept. Thank you. And if it is helpful for you, then please share with your friends. Okay.